So it measures the concentration, right? Concentration of H plus.
Wait, did you get that on video to show Everly? No.
Yeah, maybe.
No.
I don't edit it. All right. So here we go. All right, so we're going to talk about the pH of salts, and then we're going to get really in depth with neutralization. And these two concepts, they go married together. They work with titrations, which we'll get to later on. But these are like some of the most like intense topics of pH is all kind of lined up into here. Now, here's the great news. If you can unravel this, then the entire unit makes 100% perfect sense. Like everything about the unit makes perfect sense. Like this can be like a linchpin for everything else. Right? So a couple basic things. First thing, the word amphoteric just means that you can be an acid or a base. You can just do both. And that matters to what we're going to talk about. So the bicarbonate ion, the bisulfate ion are examples because the bicarbonate can donate an H and become CO3 minus 2, or it can grab an H and become H2CO3, and the negative sign just disappears. So here, let's do this one. Let's write H2PO4 as an acid and as a base. So if it's an acid, it's going to donate a proton. It's going to donate an H. So I've got H2PO4 minus. I'm going to donate my proton to water, and I'm going to get HPO4. Now, if it was originally -1 and it lost a proton, now it's -2. And then this becomes the hydronium ion, H3O+. If it acts as a base, it doesn't donate a proton, it gains one. So instead of H2PO4, it becomes H3PO4. What happens to that negative sign? It goes away, and then what are we left with? OH minus. It's not. Remember, strong acids don't go both ways. Strong acids are the ones that can't go both ways. Weak acids are the ones that can go both ways. So here's my question, guys. Who's the OG amphoteric compound? Who's universal amphoteric? H2O. Yep. H2O. You got it. Nice. Now, not everybody can be an acid or a base, and some things we know can't even be an acid or a base because they're weaker than who? As an acid, they're weaker than water. Right? Some ions are so weak that we call them pH neutral ions because what do they do to the pH? Nothing. Nada.
Wait, this NaCl doesn't do anything to the
Yep.
pH?
Nope. We're going to talk about why. Yep. So, salts. A salt is just an ionic compound, positive ion and negative ion. We can add salts to alter the pH. And then we can also add salts, I don't know why we do it, that don't alter the pH. So here's the rule. If the ions in the salts are stronger acids or bases than water, they will alter the pH. If the ions in the salt are weaker as an acid or base than water, then they don't do anything to the pH. So let's kind of show what I'm talking about. Sodium hypochlorite, if I break this apart, my two ions are Na plus and OCl minus. Is sodium, all right, as a conjugate acid, weaker or stronger than water? Weaker. What is, it comes from sodium hydroxide. That's a strong base, which means its conjugate acid is weaker than. The fact that it's so weak is why this reaction can't go backwards. OCl minus, is that the anion form of any of the 6 strong acids? Right, your 6 strong acids are HCl, I'm going to get rid of the H, Br, I, nitric, sulfuric, perchloric. Does OCl match any of those? No. So does the OCl ion, is that a conjugate base that is weaker or stronger than water? Stronger. So this will change the pH because of this. Right, so the sodium came from a strong base. So as a conjugate acid, it's weaker than water. The OCl is the conjugate base of a weak acid. So as a conjugate base, it is actually stronger than water. Look at the chlorine. Where did the chlorine come from? What acid donates Cl? HCl. Is HCl a strong acid?
Yeah.
So as a conjugate base, is Cl minus better than water? No. Ammonium, the ion, was originally the conjugate base, the base NH3. Is NH3 a strong or weak base? It's a weak base. If it's not a hydroxide, it's a weak base. So as a weak base, its conjugate acid is stronger than water. This will also affect the pH because of this. I'm going to show you some equations, Mia, because I see the puzzled look, all right? So hang tight, okay? We already said up top, guys, does sodium affect pH?
No.
Does chlorine affect pH?
No.
So sodium chloride should not change the pH. Potassium is another group 1 metal. Guys, group 1 metals never affect pH because they are conjugate acids of super strong bases. So K can't do anything. And what acid donates a nitrate ion? Nitric acid, which is one of your 6. So does this do anything to water? No. So let me show you with an equation to kind of help maybe explain this a little bit more. So NaOCl. So I'm going to take the Na ion, I'm going to take the OCl ion. You guys told me already, weaker or stronger than water, sodium? Weaker. So this reaction, the results are this. Did I make any H pluses or OH minuses? No pH change. Okay, no change in pH. Is OCl minus a stronger base than H2O? Because it's a weak acid's conjugate base. So yes, it is. So this can steal what from H2O? This can steal a proton, and I'm going to get this. What did I make? OH minuses. Does this affect pH?
Wait,
Because if this OH minus goes up, the amount of H plus ends up going down because there's a set amount. So this changes the pH. Bleach is sodium hypochlorite, which is this compound. If you test the pH of bleach, it's not neutral. Because it produces hydroxide ions, the pH is above what number? 7. That's why bleach is basic. It's alkaline because this OCl ion will steal a proton from water and produce hydroxide ions. What time is it? Okay. In sodium chloride, we already said sodium does nothing. Well, chlorine is weaker than water as a base. So can chlorine steal that proton? No, so what are my products? Cl minus and H2O. Guys, did this make any different H pluses or OH minuses? So does this affect the pH? No. See, so if it steals it, I'm going to get this, right? Let's say this stole it. No, right? So I'm going to put it down here. If it stole it, I would get this. What type of acid is this? As soon as it comes together, it's going to immediately, it's going to fall back apart again. And if it falls apart, this H plus goes right back to there, goes back to that, and this goes back to that. Like HCl, it's almost like they're like a super couple that really hates each other. If they can split, they are not getting back together. They are fiery and crazy, but if you give them a chance to break apart, they are getting as far away from each other as possible. And they're not coming back together. They are much happier because chemistry-wise, chlorine is totally cool being negative. It's like, yeah, I'm totally fine like this. I don't need you. I'm cool. All right. OCl is like, I feel naked without my H. So it's like, give me your H. I need it because it's strong. So it's steel. It mugs the H out. We get this thing again, and this becomes OH minus. So those weak acids or bases, they are conjugates. So they feel either naked if they're an acid and they have to go backwards to become clothed again, or if it's a base, if I get ate too much, I'm sorry, if it's an act, right? So, yeah, it's a base. So this NH4 is like, I got too many hydrogens. I am not okay. I am stuffed. So it's able to like loosen the belt, okay, give that H back, and now it's much happier like this. Like this is not okay. It's much cooler being like this.
So how do you know what it's a weak acid? I mean, a weak.
So all your strong acids, they all end, right? Cl, Bri, NO3, SO4 minus 2, ClO4 minus 1. These are minus 1s. Your bases is anything XOH. This is group 1 or 2. So any of the hydroxides, any of these as hydroxides are a strong base, and that's it. Anything else, if it's got a hydroxide, they wouldn't do that. They won't give you a hydroxide that's not a strong base. But anything else they tell you is the base is automatically a weak base. You don't ever need to memorize if it is it or what isn't a weak base. Just know what is, and then if it's not in that category, it's automatically weak. Same thing. Know your 6 strongs. If it doesn't match one of these, it's automatically weak acid. Yeah. Way easier than trying to memorize all of them. All right.